So, as I announced a bit earlier, it's time again for Milko Kostrukov and PHP Fibers. Let's hear it for Milko.
Thank you.
Welcome.
So, hello again. Long time no see. I hope you had a good time yesterday after the conference. Really did. Do a bunch of beers, restaurant dinner, it's like we're supposed to. Okay, so is this working? It's working. All right. So PHP Fibers. So it's a new feature which is coming in PHP 8.1, so the next stable version. And for me personally, this is one of the greatest features that we have had added to this language. So what PHP Fibers, what Fibers are about, they give us a native way for the very basic step, the very basic tool for having native asynchronous programming. Now, we can argue that we have some sort of native way to do asynchronous programming, because we already have frameworks and the tools to do asynchronous programming with PHP. And that we have native means to do so by using generators. But it's really, I really wouldn't agree with that, because generators were not designed for that. We can use that. We can use generators for asynchronous programming. It's a little bit hackish. And, well, it's not a little bit hackish. Anyways, it's a little bit hackish, and Fibers, they save a lot of time and a lot of boilerplate code that needs to be to surround the generator thing. Anyway, we won't be talking about generators and promises and what we have done, what we have been doing so far, because this will take way too long. We'll just focus on Fibers. However, Fibers by themselves really don't give you too much. So most probably, most of you, if not everybody, will not ever use them in their userland code. Fibers are by design intended for usage of library and framework authors in order to aid their jobs. But this will reflect the whole, everybody that are stepping on their tools, because Fibers are designed in a way that you can actually make your PHP code, which is currently synchronous, asynchronous without too much hassle. So, as I said, on their own, they're not too much. So this talk is basically going to be in two parts. We're going to be looking through a lot of code. I hope the code is readable. If it's not readable, we'll be zooming out and in, like on the fly. We'll see. I think it should be readable. So we will have a lot of code. Sorry for that, but that's how it works. And we'll start with just giving some context. And we'll need to create a loop, because something has to drive the Fibers. So if you're aware what an event loop is, or how asynchronous programming works, first part of the talk is maybe going to be a bit boring for you, but sorry, we have to give the context, because again, on their own, they're pretty much useless. So yeah, that's me. I'm Milko, not important. So we're going to start with a task. And the task is to download 2 files as fast as possible. And what we have built in with PHP, that's, okay, is this readable? I think it's readable. Is it readable? Yeah. Okay, cool. So the normal way to do it, the fastest, easiest thing to do is just file 1, file get contents, example, file 1 text, file 2, file get contents, example, com file 2, and we have the files. So that's great. Problem is, it's pretty slow. Why is it slow? Well, basically, when we try to, when we have any sort of async, when we have any sort of input-output operation, most of the time our CPU just waits for data, because compared to what it can do, data comes in super slow. So it's just waiting. Most of the time, it's waiting. And now this is an imaginary graph. But what we have here is, while the line is at the low, we're not receiving data. When it's up there, we're receiving data. So basically, and here we have some sort of time units. Let's time unit, whatever, seconds, milliseconds, doesn't matter. So when we start downloading the file, we get a piece of data, then we wait for another piece of data, then we get a little bit more data, then we wait a little bit more, then we get a little bit more data, then we wait some more, and it goes on like this. This piece is here. Our machine is doing nothing. It's just waiting, and that's it. Wasted time. Fetching file 2 looks in a similar way, but because it's from a different server, or I don't know, it's both example.com, but it's a cloud infrastructure, so it's faster. It downloads in 12 units of time, and it's again, like we get some data, then we wait, then we get a little more, then we wait, and so on and so forth, until we get the whole file for 12 units of time. So the thing is that we have to wait for file 1, we have to wait for file 2. We download the 2 files for 32 units of time. Okay? So the question is, can we do something while we wait? Can't we, like, instead of waiting for file 1, can we just, have a bit of here, have a bit of file 1, have a bit of file 2, and this is the asynchronous way. Like we request file 1, we request file 2, then we get a bit of file 1, then we get a bit of file 2, then we get a bit of file 1, yada, yada, yada. Then we download file 2, then we get a bit of file 1, a bit of file 1, and file 1 is done. And it kind of starts beginning to look like this. So simultaneous download for the total of 20 units of time. And yeah, so we saved 12 units of time, because our download takes as long as the longest, as much as the longest download. Okay. So how do we achieve that? First, file get contents. Well, it gets the file, but we need to replace the file get contents with something of our own. So we're going to start writing our own thing. First, so let's call this function fetch URL. We're going to pass in a string, then we're going to open a stream client to URL at port 80, yada, yada, some parameters, we don't care about them right now. We're going to throw an exception, all this boilerplate stuff. This is the important part, stream set blocking. And stream set blocking, we pass in the file pointer and false. False means do not block when you read data from that. And do not block means when I read from this stream, give me everything there is and continue. If there is nothing, you just get nothing. But continue, do not block, do not wait for data, just go. And then we do a file write here. So we request the data using HTTP 1.0 because we want to be super simple. Then we have the contents here, a content variable, and we start a loop. And until the file ends, we read 100 bytes of data. Maybe there will be 100 bytes, maybe there will be 50 bytes, maybe there will be 0 bytes, it doesn't matter. This file gets here, will return whatever is in the buffer. It may be nothing, it may be a little bit, we don't know. We'll concatenate with what we have, and we'll loop until this is over, and then we'll return the content. Now, the important part here is that this is a non-blocking function. This will not block, this will not stop. However, it doesn't solve our problem because we still have our loop, so this function will still wait for the whole file. So what we need to do is somehow get rid of this loop. We don't want this here, and still we need it. So let's refactor a bit more. Let's create a class. But yeah, first let's analyze a little bit. We can say that we have 3 parts here. It's start, this is the start, then we have reading, and then we finish with returning the contents. So let's break this down into a class. We'll call it URL fetcher, and we'll have a start method. The start method is going to open the stream socket, throw the exception, set the blocking to false, and do the request. Then we're going to have another method that's going to be called read some bytes, because it's going to be reading some bytes. And in this method, it's going to just read whatever's in the buffer and concatenate it with whatever we have, and we're going to check whether the whole thing is done. So far clear? Okay? Yeah? Okay, good. Now, we're going to refactor our function to use this class. Click. What's up, man? Click. Are we working today? What's going on? Sorry. Yeah, great. Why? Why not? I'm sorry, a little technical. No, it froze. It's not the clicker. The clicker is working. Just the connection between the 11. No. It's not the clicker. It's not the clicker. It's my something happened. We'll just. Crap. I'm sorry about that. Have to start again. I'm sorry. Stuff like this happens. You know, you work with computers, so. Yeah. Aha, okay, no internet. That's great. And of course, it's getting deeper. Rabbit hole's getting deeper. All right. Okay, wait. Fucking amazing, of course. All right, are we working now? Again? No? No? You don't like it? Okay. Hotspot. I got the package. I got the 200 megabytes, man. Smarty. Did you buy one? No, I didn't. Yeah, see? Tethering. Wi-Fi. No, not bridge. Oh, God. It's so annoying. Please don't connect to my hotspot. It's gonna cost me. All right. Cool. We're getting there.
This wouldn't happen if you were using
All right. Come on. What's wrong? Like internet in Serbia fell down? Like what's going on? It doesn't happen? But seriously? Okay, which one? Sorry.
problem. It seems that we have a short network problem, but we're working on it.
It's okay. Yeah. Yeah, I figured. There should be like I can't see this one. Like, yeah, Mikhail's iPhone. I can see it. And which one is yours?
It should say Elijah.
All right, let's restart the.
There is me.
Okay.
Let me type you the password.
Yeah, go ahead, please. Mikhail, thanks. Well, I won't throw it. Come on, man. Like, can you pass it? Thanks. Yeah, cool. Thanks.
Calls just decline.
Yeah, okay. Thank you very much. All right, let's get this going again. You know, amateur stuff. I should download this crap. But no, back. Oh, for fuck's sake. All right. Speaker view. Not this one. Oh, God. All right. This comes to me. Okay. Start presenting. Fuck yeah. Thank you very much. Okay, so yeah, sorry about that. All right, so we got the class thing, so we're refactoring our function to use the class. Get back, roll. So, we refactor the function to use our class, so it looks like this. We create a new URL fetcher. We call the start method, and again, we have the loop. While the fetcher is done, read some bytes, and then return the content. Still got this loop. We want to get rid of the loop. So, we need the loop. I mean, on one hand, we need the loop because something needs to drive the whole reading process, but we don't want the loop to stop. We don't want to get stuck in it. So we're going to write another class, and we're going to call it loop. Okay, let me get this out of the way. All right. Yeah, now, oh God. it's, all right, cool. We should be fine now. All right, again. So we're going to write this very simple class that is a loop. And a popular name is an event loop, but I don't want to call this an event loop because there are no events here involved. It's just a loop. So this class is going to have, it's going to be fully static. We don't care. Crappy code, I don't care. It's an example. So it's going to have an array of callbacks. We're going to have a public function that will, a method that will allow us to add a callback, and we're going to have a method that is called run. Now, when we call the method run, it's going to start taking callbacks from this array, like one at a time. And it's going to, this callbacks thing is going to be a first in, first out queue. That's what we're using it for. So what we're going to do until there are callbacks in the stack, we're going to take one callback and call it. That's the whole thing that it does. And once we call run, this thing can virtually run forever. This may be an infinite loop. Why? Well, because the callbacks that we're executing here, they can add other callbacks to the stack. So this can actually run forever depending on whether there is something adding more and more and more. Okay, so pretty simple, I think. And now we're going to refactor some more. We're going to do our URL fetcher class, work with this loop, with this external loop. Now, because when we call the function that will start downloading, it will exit immediately. We cannot just return the contents of what we get. We don't know when the contents are going to be there, so we need to add 2 more callbacks. And this is the done callback. We're going to call this done callback when we're done. And we're going to call, we have an on error callback, and we're going to call this if there is an error. So let's refactor some more. The start is pretty much the same, but when we call start, it will add a function on the loop, and the function will call the function tick. So the function tick, that's a new one, the method tick. We'll check if we're done, we'll close the stream, and we'll call the done callback here with the contents that we've downloaded. If we're not done, we'll read some bytes, and we'll add another function on the loop that will call tick. So once the loop starts running, we'll call tick. It will call tick again and again and again and again and again until we're done. Okay, cool. And here below, it's the read some bytes, and the other one is done method. They're not interesting. Okay, we're getting there. So now we're going to refactor our own function again. And this time it's going to be like this. Okay, we're going to create the new URL fetcher. Oh, first we're going to add some callbacks here. So except for the URL, we're going to have a callback for when we're done, and a callback for when an error occurs. We're going to instantiate the fetcher, and we're going to pass in the done and on error. The reason I'm calling the closure from callable is because we cannot hint as a callable, but we can hint properties as closures, but we need to transform the callable into a closure. So yeah, it's just it's a PHP thing. And once we create the URL fetcher, we're going to add a function to the loop that's going to call the start method. So essentially, this doesn't do much. Until we call run on the loop, nothing happens. We just stack functions. And then our main function will look like this. We'll add a big function that will go like, OK, I'm fetching dir bg. That's a Bulgarian site, doesn't matter. We're going to call this URL. We're going to add this callback for when we're done. It's going to say got dir bg. This for when there is an error. Then we're going to say, OK, I'm fetching Google now. And again, it's pretty much the same. It will go like echo got Google. Size is Google returns quite a lot of bytes. It's just not practical to display the whole thing. So we're going to say how much bytes it returns. The on error, and then once we add all this crap, we're going to call the loop run here. This is like super important. If we don't call this, like nothing will happen. And we're going to get some output that's going to look like this: fetching dir bg, fetching Google.com, got dir bg. The reason it's first is just because it's super short, not because we called it first. And when you call dir bg like this, it just tells you that it's moved. So that's everything we get. And from Google, we get 51,803 bytes. Yeah. So this is an asynchronous thing. With JavaScript, if you've done JavaScript before promises, it looked like this. People tend to call this the callback hell because, like, look, it's fucking hellish. I was when creating this slide, I was like thinking maybe I should come up with a more complex example. So, for example, we want to download file A and file B, but depending on the contents of file 1, we need to download file C or file D, and then in those callbacks we add more callbacks, and it gets deeper and deeper. But then I decided, okay, this is just ugly enough. That's fine. That's fucked up. So far so bad. That's the situation is so far so bad. We got some sort of asynchronous downloads. It's ugly as fuck. Like just not good. Not good. Okay, so fibers. Now, before I continue with fibers, I would like to say this is actually a version 2 of another talk that I prepared like maybe half a year ago, and it started again like this with the loop, but it continued with explaining what a promise is, and then looking into generators and how we can combine promises and generators and wrap this whole thing up so we can use yields in order to make our code look somewhat like more synchronous stuff. It takes about two times more than explaining, like the promise is pretty much as long as the loop thing, and then the generator is pretty much as long as the loop thing, and then the wrapping of those two together is also pretty much as the loop thing. And now I only have to explain about fibers. So this is the value of fibers. Like even the talk is shorter and easier. So the problem that we faced in this crap is that it looks like crap. It doesn't feel right. Nothing like it is asynchronous, but the code is also messed up. We don't know what like you cannot just read the code. It's messy. What we want is to be able to do asynchronous programming. So have the do this, do that, do this, do that. But when we read our code, we want it to read like a synchronous thing because it's easier. Like our minds are like do this, do this, do this, do this, do this, do this. So that's what we want to achieve. Fibers to the rescue. So what can fibers do for us? So first of all, they execute code. It's our code. They execute our code. But check this out. They can suspend their execution. So at some point, it's like running, and then it goes like, OK, I'm going to stop here for a while. And I'm going to return the control to whatever called me. And then whatever called them, it can resume. Like just, OK, continue from where you stopped. So we can do the stop, right? And also, when they stop, they can spit out a value. And when you resume, you can inject another value, but more on that later. So let's look at the class. Now, obviously, those are implemented here. I mean, it's just a mock thing that I got in order to get my IDE to understand fibers, because it still didn't at the time being. So the fiber class, the constructor, it takes a callable, and this is going to be the our code that's going to get executed by the fiber when we start it. It's got a start method, and when you call the start method, it starts executing the code we passed, because when you just created it, nothing happens, you just have an object. When you call start, it actually starts executing the callback. The arguments that we can pass into the start get passed into our callback. When the start method returns a value, more on that later, we can resume when the fiber is suspended, a little bit more about the suspension a bit later. We can resume with a value, so this is how we inject stuff into our callback. We can troll. Is started, is suspended, is running, is terminated, and they're pretty much self-explanatory. And get return, this will return whatever our callback returned when it ended. And those two here, those static methods, those are like, this is like the super important part. Get current, it's a static method on the fiber. When you call get current, by the way, I'm not sure, but maybe then the name of this method changed at some point. I'm not sure. Anyway, when we call get current, the get current will return the fiber that is currently being executed. We'll see why this is important a bit later. And when we call suspend, it will stop execution of the fiber that is currently being executed. When we call suspend with some sort of a value, this value will get returned. So for example, when you call start, it runs, you call suspend with a value, this is the value that's going to get returned by start. When you call resume, so the calling fiber will block into the resume. When you call suspend, when resume will return the value that was passed into the suspend. We'll see an actual example of that. There is a reflection class for fibers. We don't really care about this right now. Just put it here so we know that there is a reflection class on fiber. You can get the fiber, you can get the executing file, yada, yada, yada stuff. It's not really like that big a deal. Okay, so let's play with this. So let's play with a fiber. We're going to have this function here. It's going to echo, this is fiber, and it's going to echo the name that we passed in, awaiting to be resumed. And then it's going to suspend. It's going to suspend with the name we passed. And we're going to assign whatever is passed into the resume method to input. And then we're going to say, OK, echo name is from the input, from whatever input variable is, guys. And we're going to return the name. I was lazy. I didn't come up with more interesting stuff to return and to pass in and out. So we create one fiber with the function echo and a second fiber with the function echo. And we're going to start by calling Optimus. And when we start, this will happen. We will get this is fiber Optimus awaiting to be resumed. And it will stop. And it will stop. And R11 is supposed to have whatever name is. Then we're going to start fiber 2 with Megatron. And this is going to print out, this is fiber Megatron awaiting to be resumed. Now, in our main thread, we're going to say, OK, echo, F1 was suspended with whatever is in R11. So that's F1 was suspended with Optimus, because this is what we returned. F2 was suspended with R22. This is F2 was suspended with Megatron. Now we're going to resume, but in the other way around. We're going to mix them a bit. So we're first going to resume the second fiber. And we're going to get this Megatron is from the bad guys. And then the function will return. And we'll get, again here, we'll call F1 resume with good. And it will tell us Optimus is from the good guys. And then we're back in the main, and it will say like F1 returned Optimus, because this is what we return here. F2 returned Megatron. So pretty cool stuff. You know, we can juggle with code now. Nice. I like that. We can nest them. This is getting like fucked up. It's nice. So we're going to create a fiber that is going to create, it's going to echo, it's going to create another fiber. Another fiber is going to echo as well. So from within the top fiber, we're going to, yeah, okay, so just as set. Swipe to answer. No, I don't want to. Yeah, there we go. So yeah, we're going to create, from within the top fiber, we're going to create a nested fiber. In the top fiber, we're going to start the nested fiber. Then we're going to echo that we're ending, and we're going to return the fiber. And in the main, we're going to start the top. We're going to get the nested fiber from the top one, and we're going to resume the nested. So it looks like this: starting top fiber, there, starting top fiber. Then it creates the nested. It starts the nested, so it's starting nested fiber. Then, because we suspend here, we get ending top. Then we return the nested, and we resume it from the main. We get ending nested. So nice. We can totally fuck this stuff. Okay, so how this works. Now, I'm not totally into C and low-level PHP, so please don't ask me too many questions. I probably won't be able to answer, but basically this is what happens. So each fiber has its own stack, and when you suspend the fiber, what happens is that this stack gets copied in the memory and is replaced by the stack of the fiber that started the suspended stack. And when you resume, then the opposite happens. It swaps them. So basically, you have a stack, put it on somewhere there, replace it with another stack. Then you switch fibers. OK, do this again. And you can have many stacks in memory, no problem. Just have as many as you want. And you cannot suspend the main thread. Not the main thread, but the main fiber. So you can suspend only code that is called from within a fiber, which makes sense. OK, so let's go back to our function. We're going to refactor it yet again, but this time with fibers. Oh, actually, we're not going to refactor it. Sorry, we're going to wrap it. So we're going to create a new function that's called f for fibers, fetch URL, like smart, f fetch URL. And what f fetch URL is going to do, it's going to take only a URL. Like, it doesn't have callbacks here. We don't care about this. It's going to create a fiber. Sorry. It's going to get the current fiber that we're working in. We're going to call fetch URL, and we're going to give a done callback, which would resume the current fiber. We have not suspended it yet, but we are going to suspend it. We'll need to resume it when we're done fetching the file. And for an error, we're going to throw an exception. And then we're going to say, OK, fiber suspend. And that's it. That's it. That's all this function does. We're going to need, well, we're not needing it, but it's nice to have a helper function for a little bit later, for the next slide. We're going to call this defer. It can be called a coroutine or goal or whatever. What it does is you pass in a callback, a coroutine. The function is going to create a fiber with the coroutine, and it's going to add a function on our loop to start the fiber. OK? And now our main will look something like this. First, we're going to defer a function which is going to start fetching DIRBG. Then we're going to defer another function that is going to start fetching Google. And then we're going to run the loop. Now, I want you to notice how these functions are written. There are no callbacks here. DIRBG equals f fetch URL. This will start doing this whole give me some. It will use the loop, but our function doesn't know about that. It doesn't look like that. It looks perfectly synchronous. And we got a normal try catch for the exception, so it's like beauty. It reads like normal code, but behind the scenes, we're doing all this. And this is the output that we're getting. It's the same output that we did get when we, for whatever reason, Google has returned something bigger. But anyway, we're going to get the same output that we got with our super ugly crap callback function. And we're done, like super nice. If you're using AMP or something like that, those functions can look in a similar way, but they will have to have the yield keyword here. And because they will have the yield keyword here, those functions that you have will turn into generators. And yeah, why is this suboptimal? Well, the thing is that once you have a generator, it's not actually a function anymore, it's a generator. And if you want to yield from the generator to make it look synchronous, the functions that are calling it will also have to be generators, and so on and so forth. So if you actually want to have synchronous code and you want to turn it into asynchronous at some point in time, well, then you have to, at some point, everything along the line, everything that's calling this code have to become a generator. You have to rewrite all your functions. But with this, fibers, you don't have to do this. Just at some very, very low level, like you have your code, it's synchronous, but for whatever reason you decided it want to be asynchronous, well, you go to the place where you want to have your asynchronous stuff happen. So for example, query to a database or a DLL file, and you turn this into asynchronous code. Only there, everything else works. It doesn't know. It's beautiful. It's how asynchronous programming should be done, I think. I'm talking about single-threaded asynchronous, the so-called green threads. This is also called green threads. Okay, so let's recap up to here, because it's a bit messy, but you know it's asynchronous, so it's messy. So fibers, they're not intended for end-user usage. Like, as I said in the beginning, probably most of you will not touch a fiber ever in their life unless you're doing a rather low level, some sort of a library or framework for the things that you're using. They're intended for asynchronous library and framework users. So the benefits for authors. No boilerplate needed. You don't need the promises. You don't need generator wrappers. You don't need all this complexity at all. Like that's great. Benefits for authors and users. No red and blue functions. I had to change the names of those. So red and blue functions, there is this blog post about how there are red functions and blue functions. What they are describing is asynchronous functions and synchronous functions. So the crappy part about having asynchronous and synchronous functions is that if you have an asynchronous function, as I said, somewhere along the line, everything that's using it has to be asynchronous now. So refactoring is shit, like problem. If you have to turn synchronous code into asynchronous code, you're in some fun. You're in for some fun. And yeah, the other benefit is that old synchronous code can be somewhat easily refactored to be asynchronous. I mean, it's still not going to be, super easy, but at least you focus on the points that actually need to be asynchronous. You don't have to go through all your code base. So it's really nice. Now, for those of you who know about generators and how they're used in asynchronous frameworks, there are similarities and differences. So similarities are, they both can suspend themselves. They both can be resumed. They can spit something out. Remember, when you suspend, you can spit something out. Generators can do that as well. And when you resume, you can receive something in. Generators can do this as well. Now, the differences. The major difference between fibers and generators is that if you're running in a fiber, you can suspend the fiber from wherever you are at the stack. And a generator can suspend only itself. So you cannot, if your generator calls a function, this is the function that's being coded cannot suspend the generator that coded. But if your function in a fiber calls another function, the code function can suspend the fiber. So you can suspend it anywhere. And this is like super important. This is where the magic happens. So the fiber that you're running, it can be accessed anywhere on the stack. So this is pretty much same. Like the 1 and 2 are connected. You don't need the yield keyword, and this keeps your functions just normal functions. They are no generator or a function, or asynchronous function and synchronous. They're just functions. They're fine, no problem. And of course, fibers cannot be iterated on. That's kind of like, normal, because they're not generators. And Next thing, compare it to threads. So fibers run in a single thread. So you can have multiple fibers running, they're running on a single thread. It's the developer's job to switch between different fibers. It's up to you to decide when a fiber should switch to another fiber, when they should stop, when they should be resumed. It's up to you. They're rather cheap to switch because all you have to do is like just copy paste some memory here and there. And they execute one at a time. That means because they're in a single thread, you cannot have multiple fibers running at the same time. You know, you can suspend the fiber and run another fiber, but they're not running in parallel. And they're good for input and output intensive stuff. Well, why? Because when you're doing input and output, you're doing a lot of switching. So threads, on the other hand, well, they're switched by the operating system or the virtual machine that you're using. So you have no control whatsoever when your threads get switched. They're not as cheap to switch as a fiber because you have to do system. It's the system that needs to do it. It needs to go through hardware. Through hardware interruptions. There's a bunch of other stuff that's going on. I'm not super expert, but cool part about threads is that they can actually execute in parallel. So if you have a multi-processor, so we all have, you can basically have the 2 or 3 or 4 as many cores you have tasks running in parallel, in actual parallel. And because of that, they're actually good for computationally intensive stuff. Because if you have computationally intensive stuff that will run for a long time on a fiber, this will block your whole process. Because remember, fibers, they seem like they run in parallel, but they don't actually run in parallel. One fiber has to finish in order for the other one to continue. So for example, if you call sleep on a fiber, the sleep function, everything will block. So you have to be careful. Well, if you call a sleep in a thread, the other thread will just go on. They run in parallel. So pretty much that's it, I think. Fibers are pretty cool. Fibers are going to allow us to have easy and nice, I would say the more languages that they have, asynchronous programming. It's going to look good. It will not solve all of the problems of asynchronous programming. You're still going to have the usual crap, but it will be a little bit better for user land. And because you don't have to refactor, this for me adds a lot of value, this not having the asynchronous and synchronous functions. So that's it for this talk. Thank you very much. If there are any questions, of course, I'm here.
Do we have any questions for Milko?
Yep,
Yeah, we do. Just a second. Here's the mic.
So thank you for presentation. It's very nice.
Thank you.
This question, I don't know, it could be maybe stupid, but...
No stupid questions. Well, actually,
okay.
there are.
So you said that fibers can be stopped or resumed from wherever in the code. Can we also get like the list of the fibers that we can stop? So like, for example, you have like 100 fibers.
You have, sorry, what fibers?
So let's say you do make processes, you have like 100 fibers.
Mm-hmm.
And how can you be sure that some of those fibers are still running if you want to stop them? So, for example... Yeah.
Yep. Yep. I think I understood your question. It's not stupid, but it doesn't make a lot of sense. And here is why. You're thinking more about threads. So if a thread is running, you have to check whether it's still running. If you're at the place of checking with a fiber, if you're at the place where the check happens, the fiber is not running. The code that is checking the fibers is running, because you can run only one thing at a time.
Okay.
You go like, okay, you run, and it's the fiber that decides when to stop, and it gives control back to you. So now if you're checking whether it's running, it's not. It's the checker that is running. So you say like, okay, you have 100 fibers. Fiber 1, go. That's it. You lose control. It's the fiber that has the control now.
Okay.
It's up to the code that's in the fiber to decide whether this fiber will stop or not. Maybe it won't. Maybe it will just run forever. It will never return to your code. If it stops, then it's not running. If you're here, like you go, if I have control, no, it's not running. So no really need to check. If you're at the checker code, it's not running.
Okay, so yeah, that answers a part of the question. The other part is, if there are other fibers on stack, can we know which one of them are to check?
Can you, sorry?
So you said there is a stack of fibers, and they are waiting for execution. So if can you list them and say, I want to run fiber 50, and there is no fiber 50?
No, because the fiber is in a. You cannot do that, because in order to have, you can't run. In order to start a fiber, you have to have a reference to it, because the fiber from the calling code, from the perspective of the code that is starting the fiber, it's an object in a variable. So if you don't have the variable, you cannot call it. I mean, like, no, because as I said, you are managing them. You have to have references for them.
There is no integrated references for all the fibers. You have to keep them somewhere.
No, you have to have references for them.
Oh, okay.
Like it needs to be somewhere in a variable, and the calling code has access to the fibers only that it has created. But from within the stack, down the stack, then you can suspend the fiber that you're running, but only this fiber. You cannot just suspend or call a random fiber. You can create a new fiber from within a fiber, and then the code in the fiber will have a reference to another fiber, and so on and so forth. But if you're suspending a fiber, you can suspend only the current fiber, and it will go up one level. And up one level, you have to have a reference to other fibers, because they're just objects. It will start from where the start. It will continue from where the start method was called.
Okay.
Yeah, okay. It'd be easier, as a matter of fact, if we have some sort of a writing or drawing thing in order to visualize this. So maybe outside, I'll get some pen or something, and we can draw this in order to get it. Okay.
Okay.
All right. Question there.
Another question, yeah.
Yeah, actually, it's more of a comment, because I think this question actually highlights. You also talked about it, that fibers are like low-level infrastructure.
What, sorry?
Fibers are low-level infrastructure, right?
What infrastructure?
Low-level.
Low level, yeah.
And the infrastructure that's actually will be keeping track of the different fibers that are being executed would be the library that you're using, like AMP-PHP or something similar. So at this level, you would be able to have some introspection about which tasks you would be running at the same time. But not with the fibers themselves. Just to point that out.
Yep.
Any more comments or questions? Yeah.
Oops, sorry.
This is called back and forth.
Can we implement some mechanism for promise, like any raise or all for fibers?
Sorry,
like in JavaScript, we have a promise raise, promise any, or promise all. Like for asynchronous mechanism.
Yeah, I guess, but why do you need that? I mean, the whole deal with the fibers is that you don't actually need promises. But yeah, you can. You can actually you can. Of course you can. Yeah. Why? Yeah. I was not right. You can. It's easy. Yeah. I mean, if you create some sort of a wrapping function or object, it will just start the fibers. But no, that's a good question. Wait. I have to think about this. Yeah, you should be able, as a matter of fact, to do something like this, but I have to think about how this can be implemented. Okay. But yeah, totally, you should be able to do that. Yeah, maybe you can wrap a bunch of fibers into one fiber. Okay, I'll have to think about this. But I'm sure that you can do it. I just have to think about how exactly that.
We're going to need the drawing board a lot after.
Yeah.
Another question? comment or dilemma? Oh, yeah.
I'm sorry if you can put the last slide again.
Yeah, sure.
Because
Oh, just a second.
Yeah, we
Režija,
need to.
režija, treba nam ponovno posljednji slajd?
okay, so there is.
Yeah, thank you.
This one?
No, that's not the last one. Like when comparing the fibers to threads.
Threads, okay.
Okay, so basically, I just wanted to make sure that I kind of get it. So when we're saying that from the operating system, like operating system is kind of switching the threads and operating threads, and one thread can like run multiple processes. One of those processes can be, for example, my PHP script, right? And the fiber is actually just it's a part of my PHP script, right?
It's part of your, it's part of yours.
So it's a part of one process within it that is run by a thread.
No, okay, so threads, we don't really have threads in PHP, and
Yeah, I
we're
know.
not talking about FPM. Actually, we can have threads in PHP. There is an extension for having actual threads. We do have like through an extension. So a thread, whatever, it doesn't matter if it's PHP or not. It runs a stream of code, and one thread can do one thing only. You can have fibers in threads, of course, but one thread does one thing only. I mean, it executes one stream of code. The point is that if you have two streams of code, they can get executed in parallel. While with a fiber, fibers run in one thread.
Yes.
So that's why they run one at a time. Like, run some code. If the fiber doesn't stop, it will not stop. It will just run for as much as it can. Point is that in the single thread that you're running multiple fibers, you can pretty much do what your operating system does. It's the thing is that it's not the operating system is doing it now. It's up to you to decide how to schedule the fibers.
Yeah,
it's up to the programmer.
Application level, basically, right?
Sorry?
It's on application level. I mean.
Yes, exactly. It's pretty much the developer has to do what otherwise the operating system would do with fibers, with threads. Sorry.
So essentially, we are utilizing our processing time better.
Yeah.
Okay, thanks.
Yeah, sure.
Another one? Okay. Seems that's it.
Okay.
Thank you, Milko.
Just a last word. Yeah, thank you. I'm gonna pack my stuff, and I'm going to go upstairs for beers. So please join me. We'll find a piece of paper and try to write this down and figure out what's going on. Okay.
So two of you are going to have a beer break.
Well, everybody's
applause is
invited.
okay.
Like, beer's for everybody.
Yeah,
It's
because-
good. There's a lot of fibers in beer. Albert told me.
Okay.
All right, thank you.
Enjoy your beers, your fibers, and your coffee and your sweets. See you back at 4:30 for the last talk of the day. Thank you.